Hey, welcome to section 2.1.8. What we're doing is we're just writing the rules for sequences, and we're given when n equals 1. Now, don't forget our rules. We need to find out what n equals 0 is, because that's our initial. Now, we have two types of sequences we're going to be talking about. Arithmetic, and that's our linear. So that's that y equals mx plus b. But when we're talking about sequences, we use t of n equals a times b to the n. Oh, excuse me, that's not right. It's t of n equals mn plus b. And then we have our geometric. Those are our exponentials. That's that y equals a times b to the x, or for geometric sequence notation, t of n equals a times b to the n. Arithmetic is when we're adding the same thing each time. Geometric is when we're multiplying by the same thing each time. So if we look at problem 1a, to go from 14 to 12, we're subtracting 12 and then subtracting 12 again. So that negative 12, that's our slope. What we need to do is we need to find out what term 0 is. So to go backwards, we're going to be adding 12. And 14 plus 12 is 26. So 26, that's our initial. That's our y-intercept. So t of n equals our slope, negative 12n, plus our term 0 is 26. There's our arithmetic sequence. For B, to go from 6 to 18 and 18 to 54, we're multiplying by 3 each time. Since we're multiplying by the same number, it's geometric. So t of n equals. Now, we need to go backwards to find out what term 0 is. To go backwards, we divide by 3. And 6 divided by 3 is 2. That's our starting spot. So it's going to be 2 times our multiplier 3 to the n. There's our geometric sequence. For problem C, we're given the graph. Now I'm going to write a table, n and t of n. Tables really just help me visualize a little bit better. So we need 0, 1, 2, 3. We have 3, 4, and 5. So for 3, we're at 1, and then we're at 4, and then we're at 16. So to go from 1 to 4, and then from 4 to 16, we're multiplying by 4 each time. There's our multiplier. Now we need to go backwards. So we're going to divide by 4. 1 divided by 4 is 1/4. 1/4 divided by 4 is 1/16. And 1/16 divided by 4 is 1/64. That's our initial. So you can see we're multiplying by the same number. It's a geometric sequence. T of n equals our initial 1/64, our multiplier is 4 to the n. A little bit tougher one there with the fractions. Here we're given tiles. I'm going to make a table again. Like I said, it just helps me put my information in easy to see form. We need term 0, we have term 1, term 2, and term 3. In term 1, there are 7 blocks. Then we have 12 blocks, and then we have 17 blocks. So to go from 7 to 12, and then 12 to 17, we're adding 5 each time. Since we're adding the same number, this is an arithmetic sequence. Now we need to go backwards to find our term 0. So we'd subtract 5, that brings us to 2. So our sequence t of n equals 5n plus 2. looking at E, making a table once again. New term 0, 1, 2, 3. We've got term 1 is 1, 2. We have 2 blocks. Then we've got 6 blocks, and then we have 18 blocks. So we're multiplying by 3 each time. So to go backwards, we divide by 3, which would bring us to 2/3. Because we're multiplying by the same number each time, it's geometric. So T of n equals our initial. Term 0 is 2/3. Our multiplier is 3 to the n. There's our sequence. Now, for f, n and t of n. But we're starting at term 8. I don't feel like going backwards that many times. We still need to find term 0, but I'm going to skip that a little bit in my table. I'm going to go to 5, 6, 7. We're at 8, 18, and 28. If you notice, what we're doing is we're adding 10 each time. So this is an arithmetic sequence. Since I don't feel like subtracting 10 a whole bunch, what we can do is we can find this algebraically. Y equals mx plus b. I can pick one of the points to be my x and y. I'm going to pick the 5 and the 8. And what we're going to do is we're going to solve for b, our starting point. So 8 equals, our slope is 10 times 5 plus b. 8 equals 50 plus b. Subtract 50 from both sides, negative 42 equals b. So term 0 is negative 42. We have everything we need. So T of n equals 10n minus 42. There's that arithmetic sequence. And then for part G, 17 to 12 to 7. What we're doing is we're subtracting 5 each time, making this arithmetic. So now we'd have to go back to term 0. So if we're subtracting 5 to go back, we have to add 5. 17 plus 5 is 22. So T of n equals negative 5n plus 22. There's our arithmetic sequence for part G. Let's do some more complicated ones on the next page. For A, once again, we're not given our table, but what we can do for these, since they're so spread apart, setting up my table. So we're going from 5 to 15 to 45. We're multiplying by 3 each time. So our T of n, this is geometric, excuse me. So T of n equals. Now this is something we can do for a geometric sequence. Our initial, we don't know all the way at 0. But what we could do is use term 7. And if we're going to do that, we can do 5 times our multiplier, 3, not just put to the n, but to the n minus our starting number, which is 7, term 7. And that's something special for geometry. So what we can do is if we go to part C, we're going to skip to part C now. See how we're starting at term 15? Term 15 is 10. Term 16 is 16. Term 17 is 25.6. We're not adding the same number each time, so it's got to be geometric potentially. So we can check. we can find a multiplier. So 16 divided by 10 is 1.6. That's good because we're going up. It should be greater than 1. And then 25.6 divided by 16 is 1.6 as well. So this is definitely geometric. So they don't have to keep going backwards 15 times. T of n equals. We can use this to start off with. So it's going to be 10 times our multiplier 1.6. And now instead of just using n, since we're starting on the 15th term, it's n minus 15. That's our geometric sequence. Those are a little bit trickier. Now back to part B, you can see it looks linear. So for term 11, we're at 5, 12, we're at 15, 13, we're at 25. We're adding 10 each time. This is arithmetic. Now, just like we did on a previous problem, we can use y equals mx plus b to help us solve for what the initial point would be, what our value for b is. So I'm going to pick the point 11, 5, it doesn't matter which one I pick. I can use any of them. 5 equals our slope, which is 10, times 11 plus b. 5 equals 110 plus b. Subtract 110 from both sides. b equals negative 105. So our sequence T of n equals 10 n minus 105. There's our arithmetic sequence. And then finally, part D. You can see what we're doing is we're increasing by 2,000 each time. So this is arithmetic. And what we would need to do is we need to find out what our starting point would be is year 0. Now, there's a couple different ways we could do this. Now, I could go back and write this whole thing and find the y-intercept, but since we're talking about years, what we're going to commonly do is we'll call this year 0, year 1, and year 2, where n is the number of years after 2,000. And this is going to make our lives a lot easier because now our starting point would be 100,000. So it would be T of n equals 2,000 n plus 100,000. We'll be working with that much more as the year goes on. But that's a quicker way to write that type of a sequence. All right, thank you. Keep in mind, arithmetic sequences are linear. Geometric sequences are algebraic. Linear, we're adding the same amount each time. Exponential, we're multiplying by the same number each time. Thank you, and I'll see you